So welcome back to the video. In this video we are going to study about dynamic routing part 2. In the previous video we saw about dynamic routing, why dynamic routing is preferred over static routing, the types of dynamic routing. So these are the types of dynamic routing, IGP and EGP. And then in this video we are going to look more on distance vector and link state. So what is distance vector routing protocol? So distance vector routing protocol were invented right before the link state protocol, and then the early examples are like RIP version 1 and then Cisco proprietary IGRP, which is now known as EIGRP. So distance vector protocol operate by sending the following to the direct connected neighbors, like the known distance, their known destination network, and the metric to reach the destination network. So just two things, destination network and then metric. Okay, so this method of sharing route is called routing by rumor in distance vector protocol, and this is because the router doesn't know about the neighbor beyond its neighbor. So it just knows information about its neighbor, but beyond it doesn't know anything. So it tells by only knows the information that the neighbor tells it. So let's see an example over here. So we have 4 routers over here, and then let's see R4 wants to reach R3. So like R1 tells that like I have a network 192.168.4.0. So how does it tell R3 in distance vector protocol? So R3 sends an advertisement to R2 saying that you can reach my network over here and the metric is 1. So don't worry about the metric, I'll cover soon in upcoming slides. So my metric is 1. So R2 tells R1 to reach 192.168.4.0, the metric is 2, and then later it tells R3 to reach 192.168.4.0, the metric is 3. So you can see it tells the neighbor and the metric count, okay, about the known destination and the metric count. So let's see, so this is like distance vector routing protocol. So let's see the link state routing protocol. So link state routing protocol is different from distance vector. So when using link state routing protocol, every router creates a connectivity map of the network. So to allow this every router advertises information about its interfaces, connected networks to its neighbor. So each and every router in the network tells each and every one, and then these advertisements are passed along to others routers until the all routers develop a complete map of that same network. So every router just tells everyone, unlike distance vector, like it just tells only the neighbor, and then each router independently uses this map to calculate the best route to the destination. So link state protocol use more CPU on the router because the more information is shared, and then however the link state protocol tend to be faster in reacting to the changes in the network than distance vector, obviously, like since they know they have the map of the network, so they can calculate the best route to reach the destination at any point. So let's go on seeing the dynamic routing protocol metrics, not the distance vector. So this is, I'm talking about general dynamic routing. So router's routing table contains the best route to the destination network it knows, and then if a router using dynamic routing protocol learns 2 different routes to the same destination, so how does it determine which is the best? So let's say it knows by reaching router 4 by RIP and OSPF. So which router should it like which protocol should it give preference to? So it uses metric value to value of the routes to determine which is the best. So lower the better, but like each routing protocol uses different metric to determine which route is the best. So for example, RIP uses hop count, OSPF uses cost, EIGRP uses bandwidth and delay, and ISIS uses cost. So which metric would be given more priority and which metric would be given less priority? So in order to, so for example, if router 1 needs to reach router 4, so it can either reach by R2 or R3 over here. So by RIP it is like that hop count will be 2 till R4, and then by this route will be 2 hop counts. So if it is uses OSPF, so it will just use cost like it will use this route, since the cost of this route is very less compared to this route. So how to solve this problem? So as you can see, this is the routing table over here, and this is like connected link, locally linked route and static route, and then this is AD and the metrics. I hope you remember from the routing fundamentals video of this. So in order to solve this metric problem, administrative distance were being formed. So metrics used to determine which routing protocol is preferred, since many routing protocols have different metrics, just like RIP has hop count, OSPF has cost. So routers may have overlapping routes on within a network, and it uses AD to decide which route to take. So lower the AD is preferred and indicates the routing protocol is more trustworthy. So the AD value is being considered, like lower the cost of the AD, the routing protocol is considered. So let's take the same example, which like the protocol in this will be preferred, like RIP or OSPF. So we have our AD table over here, so which tells the cost where like of each protocol. So directly connected is 0, static is 1. So we were looking about OSPF and RIP. So OSPF has a administrative distance of 110, whereas RIP has administrative distance of 120. So of course the lower the cost of AD will be chosen, so which is like more trustworthy. So of course OSPF will be chosen in this example. So don't rely on the metrics, you should rely on the AD. So that's all I wanted to tell you about dynamic routing. So in the next videos we'll just see about how RIP and OSPF and all works. So that's all for this video. Thank you.